First things first, we're going to derive an equation to describe final velocity. We're going to start by writing acceleration equals change in velocity over change in time. And all that is the definition of acceleration. In the next step, we're going to rewrite change in velocity as final velocity minus initial velocity, which is the exact same thing as change in velocity, but will allow us to solve for final velocity later. Now, all I'm going to do is rewrite the equation with final velocity on one side and everything else on the other. And what I'm going to end up with is final velocity equals initial velocity plus acceleration times change in time. This equation is not difficult to use and is extremely useful, but it's important to understand where the equation comes from in order to use it down the road. In this next sequence, we are going to investigate distance, but in order to do so, we must start with average velocity. First, I write average velocity equals change in x over change in time. This is the definition of change in velocity. Next, I rewrite the equation by multiplying both sides by change in time. Then, I flip the equation in order to have change in x on one side in order to make it easier when we simplify later. Then I rewrite change in distance as x minus x initial and set it equal to average velocity times the change in time. Finally, I end up with the equation x equals x initial plus average velocity times change in time. In order to continue, one must understand a rule called the mean speed rule, which states that as long as acceleration is constant, average velocity is equal to 1/2 times the quantity initial velocity plus final velocity. In the graph below I have drawn, you can see that the acceleration is in fact constant, as the change in y over the change of x, or slope of the velocity curve, is in fact constant, and in this example is 2. If you need more time to understand this example, feel free to pause the video and look at the graph, because it's extremely important to understand this in order to continue on in the next point. In this next example, I rewrite the mean speed rule by using the first equation that I found. Velocity equals initial velocity plus acceleration times change in time. I replace velocity with that equation and then simplify. In the end, I reach the equation average velocity equals initial velocity plus 1/2 acceleration times change in time. Finally, we're going to write an equation that completely describes distance. We're going to start with our second equation on the board, x equals x initial plus change in velocity times change in time. Next, we rewrite this equation by replacing the average velocity with our last equation on the board. Average velocity equals v initial plus 1/2 a change in time. Also at this point, I rewrite change in time as just t, as that is what's assumed when we're working kinematics problems. Finally, when simplifying, we reach the equation distance equals x initial plus v initial t plus 1/2 a t squared. For a third and final kinematics equation, we're going to start by rewriting our first kinematics equation and solving for time. After simplifying, we should reach the equation time is equal to velocity minus initial velocity over a. Solving for t will allow us to plug that right side of the equation into our second kinematics equation. In doing so, there's a ton of algebra, but I've omitted all these steps because I'm not sadistic and it would take forever to do. As a result, you just have to trust me or do it for yourself to find out if that's really what the equation is. Finally, after the algebraic simplification, I reach v squared is equal to v initial squared plus 2ax. That is the third and final kinematics equation that we'll be working with. These are the three equations we have found regarding kinematics today. It is important to remember that these equations only work when acceleration is constant. However, using one or two of these equations, you can solve almost any problem that is thrown at you.